Okay, so now we're gonna be working with a situation of marbles. Marbles are really fun to play with, and honestly, they're, with this exercise is really quite not challenging, but really tricky. But once you get the hang of it, it's really quite easy. So the first thing we have is that we have the following situation. We have a table where we have three bags in which we have four marbles in each, and the properties are as follows. It states that we have, let me just make this bigger. Imagine we have, let me just style it a bit thicker. Imagine we have this, and then imagine in bag number one, right? We have two reds, oops, two reds and two blue marbles. In bag number two, just duplicate this, put it over here, perfect. In bag number two, we have two greens, one red, and one blue. That's pretty much it. And then in number three, on there, number three, we have three green ones, oops, three green ones, and one red. That's basically what we have. So that is pretty much our situation. Just group this. Oops. Group. And then we copy. And we go to the exercise, actually. It says here that the Bernoulli, a dude, takes randomly and without us seeing, he chooses one of the bags without us seeing. And out of these, well, out of this bag, he takes out two marbles without replacement and without checking the pattern or whatever. So basically, he's taking two marbles from a random bag, and we want to calculate first, right? Calculate the probability that we get two green marbles, right? So what's the probability of that? Let's first write an event. That's the first thing we want to do. So first of all, we want to find the event in this case. So find and declare the event. So in this case, we know for a fact that he takes out two green marbles. Meaning the event is we take two green marbles. That's it. Two green marbles are taken. Right? That's it. And now we want to find the probability of this. Now, we have to remember, in this case, that we have to remember the law of total probability that says the following. Imagine we have an event X is going to be equal to the sum of this. Well, in this case we do 1, and we do probability of X given, I don't know, yi times probability of yi. That's basically our total probability. So in this case, yeah, we have to put our little marble here, our marble case, which will be the same, right? In this case, it's going to be, yeah, this is a conditional probability, right? The conditional probability as well as the probability of us getting X given we have the case yi already taken. So in this case, we have three cases. Why? Because we have three little bags. Meaning, what would be the probability of us getting two green marbles if we take bag 1? What is the probability of us getting two green marbles from how you call this, from back 2, given we take back 2, and then likewise with back 3. So what we do is we write P, A, right? And then here is going to be bag. We're going to denote B as bag. And then we're going to do bag 1 times the probability of bag 1. Then plus. Remember, the plus is an OR condition. We could choose bag 1 or bag 2 or bag 3. So plus makes sense in this case. So we do the following, and we do the same for the other 2 cases, right? So we sum them up. We remove 1, remove 2, and 2. 2, 2, 3, 3. Now, what's the probability of us getting a bag? Well, in this case, it's going to be a uniform probability because they're all the same. There are 3 bags, and we can only have 1 bag out of 3 bags, so the probability of each bag being chosen is 1/3. So we can simply write, right, that this is equal to, we delete these. Let me just erase this, actually. This is going to be 1/3, 1/3, and 1/3. Meaning we can factorize this, and we get the following, right? That's it. Now that we have this, how do we find out these different probabilities, these different conditional probabilities? Well, the first one's really easy. Because bag 1 has no green marbles, so the probability of us getting 2 marbles from bag 1 is 0. So we can write that this one is equal to 0, right? Now, what's the probability of us getting, right, from bag 2 2 green marbles? Okay, let's check this out. So what we want to do is we want to take the binomial coefficient, which is nk. So what are the different ways of us taking n from n elements, k things? What are the different ways? So in this case, and we want to, whatever. What we want to first do is we want to divide all possible outcomes, and the top we want to do the favorable outcomes. Favorable, right? That's what we want to do. So what we do, right, is we first take n and k. So we take all the possible outcomes. What are all possible outcomes? All the possible ones would be, okay, what are the different ways of us taking 2 marbles out of 4 marbles? So we're going to take 4 binomial coefficient of 2. This, if we put in the calculator, let me just take it real quick. Dang it. Have it over here. Yep. Where's my calculator, man? Oh, there it is. Sorry about that. So, if we take our calculator, this is going to be 4 factorial 2 factorial 4 minus 2 factorial. So if we do that into our calculator, we should get 2 factorial 4 minus 2 factorial. This is going to be 6. So those are 6 possible ways. So we're going to write here 6. And what are the favorable outcomes? What are the favorable outcomes? Well, the favorable ones are, simply put, let me remember. What did I do here? Right. Okay. So how many ways can we take 2 green marbles out of 2 green marbles, right? Out of 2 how you call this? Draws. 2 draws of the marbles. Like how many? We have 2 green marbles. 2 green marbles, and we have 2 draws. That's what we do. So if we put that into the calculator, it's gonna be 1. So 1. So this is gonna be the probability of us getting that in back number 2. So we do here 1/6 plus. Now let's do the same thing over here, right? In this case, we're gonna do the same thing, right? We have 4 marbles, and we have 2 draws. That's all the possible outcomes. Then we have 3 green marbles, so we have 3 green marbles, and we have 2 draws, right? That's it. If we put it, we're gonna get 3 and 6, which in this case is 1/2. So we can put that into our sum. And now we sum these up. And when we multiply and sum them up, we got 2/9, which is about 0.22, if I check correctly. And if you do by 100%, it's going to be around 22.22%. And that's how you solve the first one. So yeah. Okay, so we have this exercise, which says it's a bit confusing, but let's just go ahead and work with it. This is going to be working with conditional probabilities. So the Bernoulli guy shows us, after drawing the 2 marbles, a green marble. And he doesn't say anything about the other marble. Like he doesn't say if it's green or red or blue. He doesn't say anything. He just keeps it as a secret. And he asks us, hey, what's the probability that I took this from bag number 2? So what do we do is saying, okay, we know for a fact, let's just declare a variable, our events here. Let's say that A2 is 1 green marble. And well, B2, we know that B2 is going to be just simply put from bag 2, right? So what they're asking us is, this important part is to finding out what they want from us, and then from there we can work. So given this, it's saying here that we're given a green marble, and we want to find out whether or not it's from bag number 2. So we find out, okay, we say bag 2, what's the probability of us getting from bag 2, given we got a green marble. That's it, right? This can be defined with a probability rule, conditional probability rule. In this case, we put, in this case, like so. And this can also be rewritten with a Bayes theorem. It states that this is going to be just the same, but just swapped out, multiplied by the other one. So it's going to be A2, B2 times P B2 over P A2. So that's it. This is what we want. This is what we're going to work with. So in this case, let's first of all find out what, well, the first thing that we know is that this one is 1/3. That's pretty easy to find. We're missing this one and this one. So let's work around and first find PA2. So PA2 can be found via the rule of total probability. So I read it here. Let me just copy it because I don't want to, rewrite it. Same deal as the other exercise 8. We already know that all of these are 1/3, so we factorize and everything. We get something like so, right? Because each bag is 1/3 probability, so we just clear it out. So that's it. That's pretty much it. So what do we do next, right? Well, the first thing is we know for a fact that the probability of us getting a green marble from bag number 1 is going to be 0. because we have no green marbles there. So we can just remove the first one. So we can do something like this. Oops. We can remove the first one. Then we only have these two cases, right? That's pretty much it. So what do we do here? It's a bit confusing because we don't know any of this information. We don't know A2. But what do we know is the complements. So we know for a fact that this guy can be equal to 1 minus P A2C B2. And what's A2C? A2C would be that we get a non-green marble, right? One non-green marble. And that's pretty much what we're stating. So we are going to rewrite this as, obviously, 1/3. Then we write this guy for the first one. And we do plus 1 minus, and then this guy, but complement. So the complement, right? Let's just add up the ones, first of all. So it's going to be 2 minus, boom, this guy, and minus this guy. So we have something like that. Now, what does these mean? It means, okay, given we have back 2, what's the probability that we get a non-red, non-green marble, right? A non-green marble. So in this case, let's go first with a non-green marble. What the heck? Let me just think. Yeah. Yeah, let's go with the first one, I guess, with back number 2. Given that we have back number 2, what is the probability that we get a non-green marble, right? So a non-green marble, let's say first that we get, imagine we have this case. How many non-green marbles do we have? We have 4 marbles in total, so 4 in total, and we have 2 non-green marbles, right? So the first draw, let's say, is basically gonna be how do you call this, mate? Let me think. It's a bit confusing, mate. Right. So we have 1 red marble. So how many red marbles do we have? We have 1, and we have 4, right? Different marbles. So, and then we do the other draw, which has it's not independent. It is independent, sorry. So in this case, we're gonna take the another marble, which is gonna be the blue marble, right? And that's it. Now the other cases that we choose first the blue marble, and then the green, and then the red marble. So if we sum these up and we do whatever, we get 1/6. Meaning we get 1/3, 2 minus 1/6, right? Now in this case is yeah. So the complement is that we get no green marble. We get no green marble. This is more likely. No green marble. No green marble. So in this case, the complement would be non-green marble. So if we want to work in back number 3, and we have 2 draws, we will always get a green marble, right? Because let's say the first draw, we don't get, it's 1/4, right? Because we have only 1 red amongst 4 marbles. And then the second draw is impossible because there's no probability of us getting not a green marble. So it's going to be 0, which is 0, meaning that this cancels out, right? So once we multiply and add this up, we're going to get 11/18, right? And we go back to original formula. Okay, we know for a fact this is 11/18, right? But now we don't know what is the probability of us getting one green marble from back 2, right? Given that we chose back 2, what is the probability of us getting at least one green marble? In this case, we already found it actually, because we have it over here, right? And this is going to be basically the same as 1/6. So we simply do, right? We simply say, hold on, PA2 B2 is equal to 1 minus PA2C B2. In this case, it'll be 1 minus 1/6. So in this case, it'll be 5/6. So this is going to be 5/6. So at the end, we move out of the way. We get 5/6 times 1/3, 11/18. So at the end, we get 5/11. And that is our final solution. So yeah, the first thing that I would recommend you is understanding what's going on, right? Like you want to understand what is asking for us. So what is the condition that has already happened, and what is the condition we want to happen? Like over here, we then declare either the base formula or the normal conditional formula. In this case, yeah, we use the base formula, and we try to find all the elements one step at a time by using complements, right, and no green marble. And that's about it. So yeah, that's pretty much how you solve this. It's a bit confusing, but I think it's doable. Okay, let's just do the last one here. It says that we repeat the whole situation, but this time he shows you a red marble and says that the other one is not red. What is the probability that the other one is blue? Okay, so let's just first start with A3, declaring what A3 is. A3 is going to be the case where we get one red, and the other case is going to be A4, which is going to be we get one red and one blue, right? So we want the probability of getting one red and one blue, given that we get one red, right? So this can be given by this little guy, A4, A3, and then P over A3. That's pretty much it. So let's try to find PA3 first. PA3 can be given by 1/3, and then law of total probability. Let's just copy this guy here. We just have to change the a's. Copy, right, and paste. There we go. So what we want to do, let me just change the a's to A3. Let's go and check A3, right? So it says the probability of from bag 1, given that we chose bag 1, what's the probability of us getting exactly one red ball? Okay, so let's go to bag 1 first, and let's take a look. So bag 1, right, of getting exactly one ball, we can have two cases where we get one ball and one blue and one blue. So that's going to be 2, right? 2, and then the other one is going to be the same, right? 2 and 2. So 2. And how many cases can we have? Well, it's going to be 4 binomial coefficient. It's going to be 4/6, which is 2/3. That's it, right? In this case, you want to look at it in a more binomial coefficient way. We're basically going to say, okay, what is the probability of us starting from this one of two red balls getting like just one red ball, and then we multiply it again. Why? Because these are dependent. There are two red balls, right? So we have to multiply them. They're not mutually exclusive. They depend on each other, right? So that's it. Once we have that, that's basically the first one we have. So we're gonna write here 1/3, 2/3 plus. Now let's check this guy out, right? Oops, not here. Let's check the other one. So we have 6 possible cases, as per usual. And we want to choose, okay, what's the probability of me getting this one, right? Or with this one, or with this one, right? So we have 3/1, I think it was. Let me just check. Final outcomes. Let me just try to find the solution here. No, it's yeah. Basically, what we want to do is saying, I want to get. All right, yeah. We only have one other guy, so in this case it's going to be blue. So I want to match up with how many times I can match up my red ball with the blue ball. So that's for the blue ball. Or we can also check the red ball with 2 other green balls. So it's going to be 2 and 1. Right? This is going to give us 1/2. And then we do the same here. We first say, okay, 6. And we want to check first with this one, and this one. So it's going to be 3 and 1, right? Or 1 and 1, right? So we just simply put, let's just say, I don't know, what was the other case actually? 3 and 1. Let me just read this real quick. So we can choose either 1 and 1, which is 1 red ball with another red ball, and 1 green ball. Simply put, let's just count it if we want to look at it in an easier way. We could choose this guy with this guy with this guy with this guy, so that gives us 3 different cases, right? Or we can take this guy with this guy with this guy with this guy, another 3 cases. Or 3 times 9 is gonna be 9, right? I think that makes no sense actually. It should be 3 times 1 is gonna be 3. That makes no sense. That makes actually no sense. Let me just read this real quick and try to understand it. Okay, so we start with saying the number of possible ways to choose 1 red ball out of 1 red ball is 1 and 1. That's simply put. So how many times can we choose a red ball is 1 over 1, right? And what are the possible ways of choosing 1 green ball out of 3? Right? It's going to be 1 and 3. Oops. So the number of favorable outcomes, right? And then we do here. The number of favorable outcomes is going to be, simply put, this, right? We're gonna take here, we're gonna do, it's gonna be, how much is it? 3 over 6. So this is 1/2, basically. And now the question arises is why do we sometimes sum them and sometimes we multiply them? It was really confusing for me. This was actually, yeah, in this case it would be 2 and 1 times 2 and 1 over 4 and 2. So why do we sometimes multiply them and sometimes do we sum them up? Well, in this case, we multiply both events when they most happen together, meaning outcomes are dependent on another. This is often the case when we're looking at combinations of things happening at the same time, like choosing one item from one group and one time item from another group. So for example, in the first one, it says, we calculate total weight to draw one red ball and one blue ball from B1. So first of all, in this case, to choose one red ball out of 2, it's 2 and random coefficient 2 and 1, right? And now we want to see how many times we can choose a blue ball, right? And when we want to select one red ball and one blue ball, we multiply. So when it's an and, we multiply. In this case, right, in B2, for example, to get one red ball is just 1 and 1. That's it. And to get one red ball with a green ball, or pair the red ball with a blue ball, we do red plus green is 2 outcomes, and red plus blue is 1 outcome. So that's why we add them. That's pretty much it. So yeah, that's basically it. So we got 1/3, 2/3, 1/2, and 1/2. And now that we add them up, we get 5/9. Right? We do the same situation for PA4. Right? It's gonna be 1/3. Same thing, same thing. So we take this guy, we take this guy, right? And we know for a fact that some of these are going to be equal. So we know that this is 2/3 as well, because it makes no difference as we have only red and blue balls. Over here is 1/6 as well. Why? Because we have, what are the possibilities of getting one ball, for example, in here we say one ball, one red ball, times one blue ball and one blue ball. What are the probabilities in all the cases? 1/6. So we do 1/6 plus, and the last one, well, we have no blue ball, so it has to be 0. So at the end, we get 5/18, right? And as we know, right, A4 is a subset of A3, if you think about it. Why? Because in A3 is getting only one red ball, and we can get any other type of ball, right? Over here. And over here we have to get a red ball and a blue ball. So it's a subset of this guy. Meaning that intersection between one thing that's a subset and the other thing, imagine we have, right? Imagine this is A4, this is A3. The intersection would just be this, right? Meaning it's basically A4. Meaning, now if we go back to this, this is going to be basically A4. And then PA3. And at the end, we just have to do the 5/18 over 5/9 is equal to 1/2. And this is the solution. So yeah, it's a bit confusing with the choosing and elements and stuff and the multiplication and summing, but I think simply put, whenever we have exclusive events, mutually exclusive, it's whenever we add, right? So for example, if we go back to number 2 here, we added And why did we add? Because we said, okay, what is we just want an exclusive event where we have choose one red ball, right? or we choose, or we choose a green ball. That's it. So yeah,